everybody. All right, so let's continue with the three-sum code. So okay, so we're just gonna be returning all the triplets such that yeah, right now let's see, three triplets to hit target of 0. And left off this point, and I am going to have to review this for a second. It's been a week, probably. So let's see. Init apps. Pretty much, so we're looping through everything twice. This is what we had from last time, and this here is reason why we're looping it twice. First time we're trying to get the first triplet, and then the second one we want to get the second triplet, p1 plus 1. Then can store map of the complement to triplet, the two values, and it could have multiple same. Yeah, mapping of one complement. Be a mapping of this first one. Yeah, let's go through an example. All right, that'll make more sense. Tracer stick. Tracer. Oh. Okay, so going to the first. Let's try to. Is there a timer we can set? Yeah. Because we're here. Timer. Yeah. Just setting my own timer here just to like see what's going on, you know. See how fast I get things done. And I have to speed through this. So we have to speed through this. We cannot go too slow. So 60. We're doing an hour session. All right, start. All right. Yeah, it's not sharing that part, but okay. So here it is. I have -1 here as the first value. 1 as the first value. Complement being this is P1, P1, and this is P2. P1 and P2. Then we have complement of that. So how do we get the complement of this? So -1 plus 0 is -1, and then you just add 1 in order for it to reach 0, so the complement is 1. And then you do 0, 1 being the indices of P1 and P2. So that is the first map. After that, we move the P2 pointer all the way to the end, because we do this for the second loop here. Go through for P2 all the way from 0 to -4. That would be 0. But then we have to do these parts for too. this would be the outer loop. Outer loop. So we just do a mapping here, and we can populate all that. And then after we populate all that, then we can check once we update all the map with the first and the second pointer for where the pointer 2 goes from second index again. And update by we add to the return pointer first triplet is in the map, because might have to do 2 loops in this. Not sure about how I'll be able to. There's the first loop here, and the second loop. Once we're done with the first and second loop, it's going to be an issue. It's going to be an issue for the last loop, because once you're done with the last loop, actually, last loop is still fine. Just add your last loop is still fine, because we'll still be adding the array in the first triplet in the map, which means that it should be fine. Yeah, it should be fine. We'll be able to get all the values, but yeah, and then after that we can return 0. We already have 0 as the target. Okay, so this is the complement. So once you reach the first triplet in the map, 0, 2, down to the bottom. No, this wouldn't work. So you have 2 pointers, you have complement. I don't know if we can get everything in one loop, or one nested loop, or if we need to get another loop outside here to work with the map. If we have 3 pointers though, because in yeah, we might have to have 3 pointers. I think I did 3 pointers. We get rid of the first value. Yeah, we get rid of one of the values, so that we have p0 as constant like -4 or something. Then we could just loop through, and then if it reaches p at that point we wouldn't even need a map, and we do one p 1 -4. If it reaches -4 becomes value. Let's think about it with a map, without a map, because that's what we could do without a map. If we do brute force, we do brute force for we do a brute force, it's still fine. Yeah, if we do brute force, we should start off problems with brute force. It's easier. And after that, we can optimize it with the hash table. I wonder if it's better if we just go through all these problems first without dealing with this sort of thing. Would it help us? We just go through the 75 line problems first and look at the solutions, and then after that we can use the solutions from that to bolster our ability to tackle all the other problems. I mean, we can just go through and grind through each one of these and see if them, but it might take a long time. It might take a long time to figure out ourselves. I mean, it's already taking a long time, but we can try to. It is training, so just keep going. It's just a fun thing. You don't have to worry about failing. All right, so init map here, and then we don't. Yeah, okay. Let's do a brute force approach. Brute force. So if we have 3 pointers, loop 1, 2, 3. Okay, so we have loop where both P1s 1, 2, I, JK. That's what we typically see. I compared to end, and then it's from I to end, I plus 1 to end, and J plus 1. Then we can do that. Yeah, this should work, because you can check every single value here. We'll be able to enter something there. So if we go to this one, the loop was just taken -1, row, and then 1. But would there be any duplicates if we do this? So -1, 0, 1, all the way to -4. And then and remove this J to 1, 2, 1, 2, and 3 to end, 4 to end. Yeah, that would work. If we n minus 1, minus 2, 1, and non-inclusive. Hmm. Okay. So that would be an n cubed algorithm. For 2 sum, it is an O of n algorithm. So we should be able to optimize this to an squared algorithm. Like we do parallel. What do we? So yeah, so I think this we had a good idea. We had a good idea here because we have when we're calculating 2 sum, we are using one pointer and one map. So it would make sense for 3 sum to use 2 pointers and one map. So one table. So, but then definitely the details will be different. Here. Yeah, how does that work? Oh, okay. Okay, we have. Let's break it down some more. Okay, so you have complement, value, index. How does sum do this? So you're able to get the complement and have it to map to the value index. But if we and how do we know when we return? You know, if we see the value complement value, see the complement value, then we know hey, it is time to return. So we know that if we see a complement value, then it's time to return. Okay, since there's only one array, if we see the complement value, then we can add. But instead of returning, we can add it to add that to the return array. Okay, okay. So that's the condition. That's the condition to add to the return array if it's the first triplet is in the map. If the or the second triplet is in the map. Yeah. Yeah, second triplet. Or third triplet, I mean. The third triplet is in the map. The third triplet is in the map because you already have both triplets. The third triplet will come from the pointer 2 because pointer 2 is the leading pointer. So if we do that, then the leading pointer can use to the second pointer could be used as a leading. Yeah, so we'll be able to get it going from there. If the second pointer finds it's a value such that that value is in the map, then we can add that to the return array. Okay, so this is actually what it's kind of saying here. Third is in the map. And the third triplet is pointer 2. Point 2. Because pointer 2 is the leading pointer. But we only add that to return if pointer 2 is in the map. Does that cover all cases? That's the issue. That's what I'm worried about. Or do we have to loop through it twice? Because I'm thinking, what if we find, would it be possible to get a third pointer that we needed to populate everything first before the map before knowing? I don't think that would be possible. Yeah, that won't be possible because okay, so you're storing the third pointer for these two. So if you go here, generate another pair and store it here, then we know for sure that which a next pointer it will be covered. If it's covered in here, then we can add it. Okay. Yeah, so this is covering all the values. The first loop covers all the values for this -1 value. And then yeah, let's think about it in terms of two sum. So if you have two, if it's in the terms of two sum, your complement, you already have a complement for that value. That complement is stored at find the next value that is equal to the map, and we know that it's time to turn it from there. So there could be other values, but those values would be later on. In this case, it's the same too. There could be other values that that match the corresponding complement later on. But that's fine, because we'll be reaching them eventually anyway. At the previous pointer, previous values, but they have any other issue? No, because at that point you already have it in the map. The purpose of the map is so that you don't have to go to the preceding values, and those values that you have explored already, it is in the map. Okay. okay. That's a good pointer to think about. So the map's purpose is like a map. You have explored that before. Okay, it's pretty much like a terrain map that you have already explored. So this is to verify. It's like a verification instrument for all the values you've already traversed before, so you don't have to traverse them again. Is to validate against new values. Or is to validate new values without having to or validate new values against the ones that you've seen before. Values you've already seen. Already visited. Okay. So I'm gonna copy this, and then we'll paste that into our mistakes here, because it's more than just mistakes. It's guidance for future problems. It's like our map. So we could do this here. Then we could say gotta fix this. I don't know what happened to it. This time, you buy, sell, get, sell, stock, and then we have some. What? What happened here? Oh, there you go. I was tripping up. So, I don't know what happened to it. I think this part is saying that we should not As far as saying that we should not have indices that have, or when you have two-pointer, you shouldn't rely on sorting if the indices matter. Indices matter, don't sort. And an example of that is in TrueSum. TrueSum is indices, they do matter. So you can't sort it. But if you have TrueSum problem that is a sorted array, then that's fine. If it starts off sorted, don't sort i.e. or e. Okay. Lowest found and maximum array. Subset. Okay. What other two pointers situations do we have? See, like binary search is a two-pointer algorithm. So binary search, in search. Binary search, you do sort. Okay. Now we can add this, and okay, so we can call it states. Okay, now we can see this is the way to navigate both sum and three sum. It's because map is the let's realize what a map is useful for. Doesn't happen to it after we lost alright, fine. This player to the bottom. Yeah, we could fill that up with bucket tool. Tool, fill it with that, then name it to bot player. Save it. It's not. Activate that again. And we're good. Okay, perfect. Now we can understand what's going on here. That means that we can, with that in mind, we're mapping everything for, so we should be solid. Yeah, nice. That means that's solid, that we're solid, that it's everything else before it's already explored, and we can use that as a way to verify. And okay, so that means we can always, that means we can bring this to the top here. We add it to the return array. with this down here, using the same logic as what we did before, we can say with utmost confidence that we can use this strategy here. We can add it to the return array with the map. Then we can update the map if it's it's part of the second. Yeah, update the map here. Yeah. Then I mean, we don't have to reset map or anything. This is all just based off of the fact that everything is already mapped. Everything has been explored at the beginning. It's n-1, there should be n-1 in the first part. It starts 1 is 0, and -1 is the thing, and then that'd be n goes to end. Alright, perfect. And out of that, we can turn the return array. Okay. It looks good to me. It looks good to me, but we can through the logic here and run through an example. So 101.2, we have 0, 1, 0, 1. That's good. 2, 1. That's what we did before. Now we could do the next move. Okay, so pointer 2 is now here. Pointer 2 at 1, say, hey, -1 and 1 was 0. So we'll look for a 0. Okay, so 0. Wait. Okay. We won't do 0 because the thing is, not yet at least. So we realize, hey, we check to see if P2 is in the map. P2 is 1. 1 is in the map already. So we'll update the return array. Triplets here, in this case, would say 0, 1 as part of the 0, 1, and 2. Because that is the second index. So 0, 1, 2 indices, and 2. Now the first triplet. That should be good. That part. After that, we update the map to say, hey, if you have -1 and 1, you have 0, then -1 and 0 and 2, being the indices 0 and 2. Nice. Perfect. So now we do the same thing. Do the next. Right. Awesome. Go up to the top. Say, hey, at 2 now. What are we trying to do now? We say P1 and P2, and we're trying to see if there's any 2. 2 is 2 in the map. 2 is not in the map. So let's update the map. Let's just skip. We do not add to the return array. Update the map, which is complement 2 minus 1 is 1 minus 1 is 0. So we have 0 and 3. Perfect. So now let's go to the next value. Say, hey, -1. Is -1 in the? Yep, it is. So add, which is we have the values 0, 3, and then the current index, which is 4. So 0, 3, 4. Perfect. So hit that. So now let's move on to the next value, which is -1 and then -4. So how do we reconcile this? So -4 is not in map. So how do we do this? And it's looking for a 5 in order to reach. So -4 minus 1 is 5. 2 is 0. So now we have 0, 4. 0, 4, 0, 5. 0, 5. 1, 2, 3, 4, 5. Oh, we forgot to do the previous step. Complete the previous step, which is -1, -1. So the previous step was 2, and it's 0, 4. Perfect. Nice. So now what do you do now? We say, yo, we've done with everything. We're done with everything. Now we can do p1 next value, which is that 0. And then we say, hey, what's the value for p2 now? P2 is 1. Oh, do we have to reset the map at that point? I think we might have to reset the map. And we're in if we don't reset the map, how would it work? Because we already visited these values before. Chances are we might have duplicates. Yeah, let's roll with this first. So P1, I mean P2 is pointer 2 now. Pointer 2. Looking at yeah, we have to reset the values. Because this map is only useful for the first iteration. Because now you're gonna have duplicates. You try running it again. Right? 2p2 becomes 0, 1, 2 again. Yeah. See, duplicate. P2 is equal to 1, which is index 2, and we'll be getting a duplicate triplet again. So we gotta reset the reset map at the end of every loop, which makes sense because you're pretty much finding it's a complement. It's a complement for map that you have here is a complement for the current 2 values. The 2 pointers that have been already set. And so you'll have to reset because the complements change those 2 pointers. Because now these are the 2 pointers, and now the complements are different. Complement is definitely different. Yeah, you have duplicate. Yeah. Okay, another way to think about this is you're breaking it down into multiple two sum problems. Yeah, you're doing n two sum problems. So 3 sum is pretty much you can visualize it as equivalent to n 2 sums. Okay. So we do n times 2 sum. All right, there we go. Yeah, it would be difficult to think about this in the middle of your interview unless you've already looked into it before. So if we're doing that now. So that's pretty much what we're doing now. So you notice that it's two sum value of when -1 is set. So that's pretty much saying, oh, we have target is set different. target is different. Every time you move, this is a different target. Every time you move 0.01 is a different target. Target being negative, the previous pointer plus 0 is the target. and then after that we have the, and we have pointer 2 and we have the map. Perfect. Okay, so let's get rid of this, right? Because this is, we have hit this statement here, reset map, and then pointer 2 is like, hey, we see anything in the map? No. Let's just skip that, the second step, or then skip this part, this step, adding to the return array. Can't add anything if there's a map, you haven't explored anything anymore at this point, because you have reset. You have reset the, when pointer 1 changes, pointer 1 changes, Q1 changes. So when changing Q1, we have target changes. Is it different, aka next, do some. So right there we go, perfect. All right. So -1.2, we have, after that we set it so that it is -1 is the value, and we're trying to set the complement, and we're trying to have 1, and we know 1 and 2. Okay, so next value, move this pointer 2, that is not in here, map, so we say 2 plus 0 is 2, equal 2, 0, pointer 1, comma 3. Nice, and then we say next value, -1 minus 0, 1. Oh, -1 is in here. So let's add it to the value, the indices. Negative 1, 2, and then this is a pointer 4. Nice. Then now we add that over here, which is -1 is +1. So it's 1, comma 4. Now move this over to 4. -4 is -4 in there? Nope. So +4 is value 1, comma 5. And then we reach this set, the reset step, reset brace pointer 1 moves here, and there's no value here, so it's 2, 3, 2, comma 3, and we say, hey, -1's here and down, -1 plus 1, 0, 1, 0, so 2. Erase that. Okay, so now 3, positive 3, positive 3, and then 0, whatever. Doesn't matter because this last one we'll have to reset the map anyway. So let's reset the map. No, not P1. So that's -1 plus 1, then -1. Okay, that's 3, 4. Then we have 4. That's not it. So continue. 1, 2, and then we end the loop. Perfect. And now, so we can say we have triplets. these are the only triplets that we have. And we return, so 0, 1, 2, 1, 2, perfect, and 0, 3, 4, we got that. Then we have 1, 1, 2, 4. Yep, and we got that. And then there's nothing else. Yeah, we got everything. Is 0, 4. Yep, got that already. Yeah, perfect. So we can code this up. Let's code it up, alright? This is not as intimidating as I previously experienced it to be. It's not like intimidating at all. Alright? Let's go over to sum 3 sum second. Alright, pulling it up right now. Got it. Alright, let's go. Alright, once we wrap this up, then everything will continue tomorrow. We have other stuff today. Alright, so 3 sum, how do we do this? Initialize your variables. What variables do we need? Have a return value, which is triplets. And then we have the 2 pointers, which we know, and just do a for loop for j, for I, in range, length, nums, -1, for j in range, when nums. Then we'd say, oh, we need a map, yeah. So what's the map be called? The complement map. The complement map will be, we do a complement, reduce the complement, which is I. We're trying to reach 0, so it's pretty much negative I plus j. We do negative I plus j, that should be good. Yeah, because that would indicate 0 as complement. Okay, so if complement map no, yeah. I hit Control W. If you're a FIM user, you would understand. Complement map. Then complement map is if it's in the complement map, what do you do? Say return array triplet end our complement complement map Wait. No. Can't do that. Join. Pretty sure Python has a join function or and append concat. Yeah, concat. Is there a concat? Python. Let's see. Just gonna pull up a Python shell. Python b one pet concat 2. The join. Oh, it's the easiest way is just to ask our llama concat 2 arrays in Python. It's just a plus. I mean, that's what we did at the top too. So okay, so be complement map at complement. Now we could say that plus wait, no, not plus is alright, let's say alright, verify. So 1, 2, yeah, there it is. Yeah, easy. So we say complement the complement index. So complement is not if complement is in complement map. So we put j as the value. Yes. Not if complement is complement map. It's if j is in complement map. Comes at j. The value 1 goes to nums I plus nums j. And if nums j is in the map, then we'll append complement, which is yes, and then that j is in there. Because nums j, that means that nums j is the complement, and then we can just have those two combined together and say the triplet is satisfied. After that, we say we can join those. We add to the complement map. So if complement in complement map, wait, that's could be oh yeah, we can't just do this. It could be multiple, so we can't just combine those like that. So could you say we could have a for loop that goes through the values. So okay, so we have the indices or triplets. Triplet indices equals complement map at times j. Then for triplet indices, six indices in comp triplet indices, triplet append triplet or indices plus nouns or plus j, because and all those indices together. J is in the next. So if complement in complement index or in complement map, then we add the complement map complement plus equals, and we add the values ij, else complement. Oh, let's bring this down here. So if complement not in complement map, then we could say complement map at complement equals empty array. Then we add that there. Okay, so now that should be all set. We have to reset our complement map. Then return the triplets, and triplets here. It looks good. This is ij solutions append these plus j. This is int and list. So indices is how do we yeah, so it's I forget how we can build that sort of loop. For item thing looping items in thing objects in here. Is it equivalent of for yes for of loop in Python. How do we do that? Yeah, so for Python we have a for value in array. But yeah, triplet indices should be let's see. What happened here? Is it running? Wrong answer. map. Not complement is not in the complement map. This else we do a join with indices. See, no, I did wrong here. So oh yeah, I forgot one thing. That was one. And we don't have to hits like that. 0, 1, 2, still wrong. 0, 1, 2, 0, 3, 4, 0, 3, 4. Wait, why do we have 0, 3, 4? Oh, we do have, no, that should be right. Right? Because we're hitting -1, -1. Then output is 1, 2, 4, 1, 2, 4. Wait, why is 1, 2, 1, 2, 4? Yeah, 1, 2, 4 should be. Did I read the problem wrong? Okay, so it's doing -1, -1, 2. -1, -1, 2. Yeah. And then this is -1, 0, 1. -1, 0, 1. Yeah, that's right. Okay, so we're doing -1, 0, 1 here too, right? 0, 1, 0, 1, 1. They don't want indices in this problem. So we might have to go back to the drawing board. But it's very useful. So want indices in this problem, but we figured it out with the indices. How do we do it with the values itself? So with values themselves, you can set, and yeah, instead of having indices here, we would do triplets values for value and value. Then we say it depends, and the values the day. Yeah, if you append them, does that still suffice? Yeah, if it's a set, is a set. We have a set, and then we turn that set into a array. So the complement or the triplets is a set. It's a new set. Right. So set is here. So we do we use sets in Python? So set. No, 1 second. It just do Python 3. Or we can do that afterwards. Let's just maintain this for now. New set. What do we do with that? So we return triplets. Let's array that from. That's JavaScript. We just do array. that. Convert array to convert sets to array. Okay, so to convert array to Python would be to do a list. It's not called array. I thought it's list triplets. We add to Python list. Not list. Add to Python set. We did not add. Multiple. You could add. Dot add. Okay. Nice. We do add. Then do triplets. Okay. So we do this. Rather than doing triplets.append, the triplets.add, and we have the values plus nums at I. Save that. Then we know that Pablo is on here, so we know that we have to do nums at I. Nums at J. Then we can have, if we use a set inside, yeah, we do a set inside, so we map add. Yeah, the problem here is, yeah, it could be different orders. How do we remove duplicates? I mean, we could remove duplicates at the end if we really, but if we remove duplicates, just where that is. I don't know if there's a data structure for that because if we set it. You use sets of sets. Yeah, if you do a set of set, then that would work. You do nested sets in Python. Order set, and set. Find the inner set. Frozen set. Let's just not do that. Oh, we try frozen set. 1, 2. new set or set frozen. Do set. Huh. Ah. Hmm. Is there another way to do this? Maybe we can do a set of multiple values. Set. Huh. Okay. Realize that. Okay, that's awesome. So Python lets you handle tuples sets. So what we get to do is to complement map at complement plus equals to which here we're adding to the complement. But if that complement here is the new set, we dot add. Yeah, and we change this to a tuple. Then we can add those sets in there. Triplet add values. Okay. I mean, we could. Okay, this would work. So we do rather than set, we don't need sets in here. We just do a array. Then we say this is right here. Then we just do values. How do you extract? Combine two values in here with tuple. Convert array into tuple. Okay, so we just do tuple my array. We do this. Tuple. And combine those together. That's a value plus values triplets. And dot. Oh, we map those triplets. Triple triplets. Convert all tuples in set into array. Nice. Now we just this list tuple triplets, or I mean list triplet for triplet in triplets. All the other triplets, other tuples, they automatically remove duplicates. Could we check the theory? Let's test it out. Theory tuple. We do tuple of 1, 2, 2, 1, 2. Looks like it's doesn't deal with that. How do we? So for tuple and tuple set. So that's wrong. That would be nice though if you had a set that those tuple duplicates. for the thing. If we sort them, then that should be it. We should sort the values. Rather than doing tuples here, we just say add here, and that would do a sort on it. Sorted. So we sort those values, and then we return the triplet list of triplets. Oh, you cannot hash the. Oh. Now it's a triplet of for triplet and triplets. Hashable. I think I understand what it's saying. Let's try that. Triplets. That. All right. Okay. Can only contain this. Triplets sort and triplets. Hashable type. Oh. Is there a way to reduce the number? Sort the I feel like we got everything besides this. Right? If you have multiple zeros, triplets dot add. Okay. Now instead of concatenating, not concatenate. Yeah, we should make a new set here as well then. Set. And here we do a dot add, and then we'll sort it. We do a sort on tuples. Does sorted work on tuples sorted? How do you concatenate tuples? That doesn't work. Ah, okay. Can we change this to something else that makes it faster? We do triplets dot we can get rid of the triplet values here. Values. Okay. Then we do a triplets dot add or update add the values for triplet plus it for nums j comma where triplet uh for triplet values. Oh no. This is time exceeded over and over. How do we figure this out? This giant this suit. Human time exceeded. This is a 4I and J complement add. Java app. Let's Is there? It seems like there's a much faster way to do this. But I guess the solution we have here is correct. Just the time complexity is too extreme. Yeah, because potentially it could be a n cubed algorithm with the triplets being all in that complement. How do we speed this up? How? Addict. How's it going? Yeah, I didn't see your message till now. I don't know when you sent the message, but if you're still here, what's up? Thanks for hopping in. What's up with this though? I don't know how am I gonna figure this out though? Sweet. No idea. Or this could be oh, is n squared the fastest we can get? I think we have to look at the solutions. We already spent too many hours on this. Unfortunate. Did it beat 17%? That's funny. Hmm. Wait, let me think about this. Go back here. I just got an idea. If we sort everything, would that make it faster? Alright. Sorting. All triplets are sorted. How is that? How would that work? Sorted. Then we go through each value, and it will, if there are any duplicates, it will remove. But have solution set must not contain duplicate triplets. So if you have multiple of these, if you remove all duplicate triplets up to a maximum of 3 values, same. That would still not cover every case, because they could all be different values. And we have, but would it? Yeah, it would still be, because you could have negative values, and they could have different values for each one that are negative. Man, how we do this? How we do this? What is X range? I don't know what X range is. Not seen that before. X range. What is X range? So X range specifies a range between 0, 1, 1 and see 1 and 10. This range converted to a list. X range 1, 2, 5, 4, and 4. Python 3. X range 1, 2. X range is not a thing. 2015. So this would be using Python 2. Okay, so X range doesn't matter here. It's outdated. It is range is replaced by range in Python 2. After to Python 2. Okay. Yeah, so it could handle negative values and non-integer values. Interesting. Wow. How does that work with non-integer values? If you have range 1.2 and 4. Yeah, I don't know about that. Chief. It's says it can't handle float. Maybe there might be a different value that's not a float. That is that range works with. That's not too sure. Hmm. Yeah. So for I in range length nums minus 2 is greater than 0, the index is greater than 0, the numbers equals, or first value is equal to the second value. Continue. Wait, it's 97.4%? Wow. How do you do that? How? I how? Yeah, because they're using pointers, right? Pointers, yeah. What are we using? We're using double for loop as well. Okay, isn't that what we're doing? How? Oh, they're splitting it up so it's not as they're also using sets. P and N and P, why? Negative numbers, positive numbers, and zeros. Okay. That might make it better. Alright. We're gonna have to make another part. Just getting crazy long session. But at least we figured it, we solved it up. So solved it using our brain. So looking at the other solutions. This is issue being it's too slow Perl code. Alright, well, see you guys another time. I'll continue with this later. Bye.